Hello everyone, my name is Sri Raksha, currently studying in Sri Venkateshwara College of Engineering. In this video, I am going to discuss about the subject analysis and design of algorithms. The topic I am going to discuss is about the selection sort using brute force approach. Let's see what is brute force approach. The brute force is a straightforward method used to solve problem solving that checks every possible solution until the correct one is found. The brute force algorithms function by searching each element sequentially until the desired result is found or all the options are exhausted. This approach is used to find an optimal solution. Let's see what is selection sort. We start selection sort by scanning the entire given list to find its smallest element and exchange it with the first element and putting the smallest element in its final position, that is the sorted list. Then we scan the list starting with the second element. To find the smallest among the last, that is n minus 1 elements, and exchange it with the second element, putting the second smallest elements in its final position. Let's imagine you have an unsorted list of elements. Our goal is to sort them in an ascending order. Brute force method involves iterating through the given list of each element to find the minimum. After finding the minimum element, we swap it with an first unsorted element. This process gradually continues till we find all a sorted list of elements. Generally, on an ith pass through the list, which we number from 0 to n minus 1, the algorithm search for the smallest item among the last, that is n minus I elements, and swap it with an e of I. Let's consider e of 0 is less than or equal to e of 1, which is less than or equal to till e of I minus 1. Let it be the final position. A of I till A of minimum till A of n minus 1 be the last element. After n minus 1 passes, the list is sorted. Even though the selection sort is not efficient, but selection sort is easy to understand and implement. It has a time complexity of O n square, making it suitable for small databases. Algorithm. Selection sort, let's consider an array A of size 0 to n minus 1. Sorts a given array by selection sort. Input, an array A of size 0 to n minus 1 of orderable elements. Output will be an array of size 0 to n minus 1 sorted in an ascending or non-decreasing order. Step 1 is for I is equal to 0 to n minus 2. We have to set minimum is equal to I. For j is equal to I plus 1 to n minus 1, if a of j is less than a of minimum, we have to set minimum is equal to j. Then we have to swap a of I and a of minimum. Let's see an example. Initially, the array size B, n is equal to 7. The elements are a of 0 is equal to 42, a of 1 is equal to 16, a of 2 is 84, a of 3 is 12, a of 4 is 77, a of 5 is 26, a of 7 is 36. This is an unsorted array. Let's begin the selection sort. In the first iteration, we have to consider the first element, that is the a of 0, 42, as a minimum element. Then we have to search for the smallest element in the given array. In this given array, 12 is the smallest element. Then we have to swap the first element with the smallest element, 12. You can see here, 42 will go to A of 3 position and 12 has come to the first position. In the second iteration, we have to consider the second element because the first element, it has been the sorted element. The second element is 60 and we have to search for the smallest element in the remaining list. In the remaining list, there is no smallest elements. Since 16 is the smallest and it does not need to be moved. In the third iteration, 16 and 12, it is a sorted list. When it comes to the 84, we have to consider it as a minimum element and we have to search for the smallest element in an unsorted array. And 26, it is a next smallest element and we have to swap it to the third position, that is 84th position. 84 is swapped to 26th position and 26 number is swapped to 84th number position. In the fourth iteration, we have to consider 42 as a minimum element and we have to search for the smallest element in an unsorted list. When we compare the elements, 42 is the next smallest element. It has been already in the correct position, so no need to swap the element. In the fifth iteration, we have to compare 77, that is the minimum element. Since 12, 16, 26, 42, these are the sorted array and 77, 84, 53 is an unsorted array. So we have to consider 77 as a minimum element and among 84 and 53, 53 is the smallest element in the given data. So we have to swap 53 and 77. In the sixth iteration, the last two elements, that is 84 and 77, it is an unsorted list. So we have to compare these two. 77 is smallest when compared to 84. So the 77 element is swapped to 84th position. You can see here 84 is swapped and 77 is also swapped. So the sorted array will be 12, 16, 26, 42, 53, 77 and 84. This is unsorted array of size n, that is 7.